Hello and welcome to Tuber. My name is Buddy Galletti and my fellow teammates are Tom Smith, Hugo Campos, Stephanie Stamper, and Sam Olivas. Together we work to develop a web application where people can come together and practice the 33% rule. For those that are unfamiliar with the 33% rule, it is a philosophy that states that the best way to learn or best way to master a subject is to spend a third of your time working with your peers, a third of your time working with someone more proficient than you, and a third of your time teaching others that are less proficient than you in that subject. In this example, we focus on a college campus and reference course titles specific to that community. The problem is, where do you find these people to help you practice this learning model? That is where Tuber comes in. Tuber will match you with a fellow learner based on the role you would like to play and your proficiency level, as well as the proficiency level as others in the Tuber community, to help you maximize your learning potential. And now, Stephanie will walk you through our application.
Thanks, Buddy. So I'd like to get us started with Tuber. The first step in our application is to sign up. So we're going to go ahead and enter in the usual personal information, first name, last name, login info, and we will go ahead and hit continue, and that will bring us to the next screen. And here we are going to be prompted to just go ahead and check off any topics of interest that are on the page. We're going to go ahead and continue to our final screen where we are asked to then do a self-assessment on those topics that were just chosen. Continuing on after this, we are brought to our newly created profile page where you can see all of that info that we just entered displayed. So now I'd like to talk a little bit about our front-end technologies and design. We used React, Redux, Balma, and Sass to create our front end. Our user experience was carefully planned with detailed wireframes for ease of use and minimalist user interface. We used Balma to lay everything out on the page and then customized it for our style using CSS and Sass. We made it a goal in this project to optimize React's modularity and reusability of components in this app. I'd like to pass it off to my teammate Hugo now to continue on.
As was stated earlier, we wanted to keep this simple. And as you click this meetup button, the user is prompted to select their role for the day. At this point in this example, we assumed that the user would be a college student working on a college campus who needs help with their math course. So if they go ahead and scroll over to the Learn button, they are shown a series of courses that they're taking. And the topics that you saw them select earlier are the only ones that we use to show. We filter through each one of them so that it reduces the amount of space covering the screen. So once they select the topic that they need help for in the day, that's when our backend starts kicking in and we start having to deal with HTTP requests. So sending this submission would take an object of their information and would send it to the Express the Express server, and that would then be rerouted to a queue that we have in Postgres. This queue here will sift through all users who have been waiting to help or have been waiting to get help, and the roles are used to filter first, the topic second, and then we have to make sure that the people who are possibilities are actually going to be able to help them efficiently. So we have this sort of threshold for proficiency ratings. Once we go through the list and we've locked down some partner, we take those two users out of the list so that they don't get called by other users, move them to their own separate table, and at this point, they're assigned a meetup ID that we use to try to match them in real time. So at this point, that's when Tom Smith can explain what happens.
A really important aspect of Tuber is this emphasis on real-time communication between two potential learning partners. One way we addressed this challenge was by setting up a private chat room for two people who were paired based on subject and relative topic proficiency. This allows users to ask questions, to share ideas, to swap notes, or even make plans for a study session later on in that day. We were able to implement this feature by incorporating Socket.io, which allows users to connect in real time over our backend Node and Express servers. With that, I'll pass it off to Sam, who will close out our study session for today.
All right. So upon our users completing their meeting, they have the option to close their meetup room. After closing their meetup room, they're presented with a star rating system. The star rating system is an exponentially rated moving average, and that allows us to keep up-to-date scores on the user's proficiency levels, and also encourages the user to really expand their own knowledge base to see that reward of the star changing. Here at C, we land back on our profile, and we see our complex fractions is going to increase as we receive our proficiency rating from our tutor themselves. At this point, our student is done learning for the day, and they're going to log out of their application. So in summary, we used a variety of full stack technologies when we included continuous integration and testing using Travis as well as Jest. And our app is currently live on tuber-cpu.herokuapp.com. So feel free to go check it out there. As a team, we're planning to add a couple more features, such as geolocation, which we can incorporate into our matching algorithm, user stats to help encourage people to follow the 33% rule and what role they are mentoring, teaching, or tutoring under, and then expanding our course and topic selection to also suit the needs of other learning communities. And thank you for listening to our presentation on Tuber.
Wow, that's great. I could certainly use that.